Alright, so this problem says a small plane flies at 200 kilometers per hour in still air. If the wind blows directly out of west at 50 kilometers per hour, in what direction must the pilot head her plane to move directly north across land? How long does it take her to reach a point 300 kilometers directly north of her starting point? Alright, so what we want is okay. So the problem is to move directly north on land. So we want the velocity of the plane with respect to ground is equal to velocity of plane with respect to air plus velocity of air with respect to ground. All right. So again, we saw that if you want the velocity of an object with respect to some frame, what you can do is that velocity you can insert another letter. So we've inserted A. So again, the form. Hey guys. So what we've done is we've inserted another letter here. So what this is saying is velocity of the plane with respect to the ground is equal to velocity of the plane with respect to air plus velocity of air with respect to ground. And what does this mean? This is the wind velocity. So this vector plus this vector gives you the ground speed of the plane, or the ground velocity of the plane. Okay. And so I guess if you think about it, if you want to head north like that, you got to fly the plane like this since the wind velocity is coming like that. So here's the vector diagram of what you have of the equation above. Velocity of plane with respect to the ground is equal to velocity of the plane with respect to air plus velocity of air with respect to ground. Okay. And you saw that when you do vector additions, what you want is you want to write these vectors in unit vector notation. Okay. So what they give you is in this problem, the speed of the plane, the magnitude of this vector is 200 kilometers per hour. The magnitude of this vector is 50 kilometers per hour. Okay. And then we'll have to find the magnitude of this vector so that we can tell you how long it will take you to travel 300 kilometers. Okay. So let's write all this down. So VAG, the wind velocity is 50 I plus 0j kilometers per hour. Okay. We'll call this angle theta. In what direction? And they ask you, that's part A, in what direction must the pilot head her plane to move directly across land? Directly north across land. Okay, so we'll find that. And this is 200 kilometers per hour. Okay, so V plane with respect to air is 200 minus 200 sine theta I plus 200 cosine theta j. So that's the velocity of the plane with respect to the air. You know. And now what you want is, so again, see from okay, from this triangle you could easily calculate this side. This side is just 200 square minus 50 square and so on. So you should be able to easily calculate, but I'm writing down the general formula because in cases when the situation is more complicated, this is the way to solve it. Okay. This problem itself is fairly easy, and we don't need to be doing that. But for instance, if the wind velocity was like that, then you would need to solve it like I'm doing so. Okay. So anyway, all right. So what is it that you want? VPG, the ground velocity, has 0 x component. Okay, all it has is that. Okay, so if you look at the x components, VPG, where is that's 0 is equal to minus 200 sine theta plus 50. Okay, so what we have written is the x component of this vector is equal to the x component of this vector plus the x component of that vector. Okay, and see, from that you can calculate theta. Okay. All right, so sine theta is 50 over 200. And okay, so the pilot has to head 14.5 degrees west of north. Okay, and then the wind will blow him. With the wind velocity added, he'll be heading directly north. Okay. So now let's continue the problem. That is part A. For part B, so in keeping with this, let's do the y component of the velocity. So let's look at the y component of the velocity. The y component of these equations. So VPGY, the ground velocity y, that would give you the ground speed. Okay. And that is equal to VPAY. VPAY is that 200 cosine theta, and you just found theta. Plus, again, I'm using a hammer to kill a fly here, but you will need to learn to use this hammer later down the road. VAGY, but that has no y component. That's 0. All right, so the ground speed of the plane is 200 cosine 14.5, which is kilometers per hour, and time is distance over speed. So you're heading 300 kilometers north, 193.6 kilometers per hour. Actually, I need to take this phone call.
Hello? Hi.
All right, so this works out to 1.55 hours. Okay. Do we have any questions on that? All right.